Hello everyone. This is an additional hands-on on the topic of inheritance for the object-oriented programming course. Um, Here we will talk about one additional example about using inheritance versus using composition. So just to give you a little reminder here about the difference between uh, inheritance versus composition. Inheritance is an object-oriented fundamental principle where a subclass inherits all features from the superclass. And here we talk about all features that include data members and methods. Now, normally in inheritance is a relationship that is represented as is a relationship between the subclass and superclass. For example, in Java, we can say a student is a person. So a person is the superclass, meanwhile the student is the subclass. Normally in Java, we use the keyword extends to enable this relationship. By default, any class or user-defined class in Java is the subclass or a child of the class object. On the other hand, composition is a principle. Also, you can consider it for use, but normally it's a principle where a class can hold a reference to another object of another class. And normally this is represented in a relationship called has a relationship. For example, student has an advisor. So a student is not an advisor, however, its student has an advisor. Both two principles can be used in the context of reusing other codes or extending the functionality of other codes. Now, in both techniques, superclass and compose classes are already defined. So if you look at this example, student and person, normally we assume in most of the time that the person class is already there, it's already defined and written. Sometimes we don't have access to it. However, we would like to define the class student. The same on the same token, the advisor is already there and we would like to use it so that we can have it as a part of the student class. Now, one example I will be working on in this small tutorial is the definition of the array set. Now, it's very well known that in Java, there's the array list class under the Java utility. And normally array list is a very flexible dynamic data structure where you can hold all kinds of objects and and it has a very flexible API interface where you can add at the end, you can add at any place in the array list, and at the same time you can remove, you can do many other things there. So in this tutorial, we will see, okay, if we have arrays list and we would like to create another flavor of array list, which is array set. Array set is a class where there's no duplicates. It does not accept duplicates. So how can we do that? We will use at the first at the first part, we will use inheritance. And after that, I will show you how can we use composition to do the same exact thing. And we will see the difference between them. Okay, so let me go to NetBeans here. So this is NetBeans. I will start with inheritance. So an array set extends array list. And as you can see from this line of code, now my array set, this is the subclass that I'm trying to use or to define, is using an already defined class in Java called array list. So in this case, everything in the array list is transmitted to the array set. And as you can see in the main here, I defined one constructor using the default constructor of my array set. And I used one array which contains clearly some duplicates, 3, 3, 3, and also I have 2, and I'm adding them to my set. If I run that, you will see I am getting the same exact behavior of the array list where I can have or I can see duplicate. Now, how I can define things, or how can I prevent or redefine my array set such that I don't have any duplicate elements. Notice that there's a bunch of things where you can define, you can add things to the array set here. I'm restricting everything on array list of integers, so I will be working on only integers. So maybe the only problematic things here in adding is that when you add, when you delete, there's no problem, because element, if you delete an element, still the array or a bunch of elements will be the same. There will be no duplicate. The only thing is that when you add an element, you need to make sure that this element is not there. So you need to, again, since we are using inheritance, we need to use override. We need to override the method that misbehave. And one of them, it's clearly, I think I have it here. One of the methods clearly is adding. So if you add an integer, which is the element of the array list or the array set, you need to make sure that it's what? It's not there before you add it. So we will stick with the exact definition of add, is under array list. So here's the element. This is overriding. As you can see, I will add the annotation. Why? Because I am redefining a method in the parent, which is array list. Now, all what I'm going to say is if I have the element, or if I have contains element, okay, I can just return, do nothing, or I can return true, because I have to return true. Okay. Else, I can just, if it's not there, I can add it. So I can say add element. Notice that there's a problematic thing here. Of course, I have to say return so that I can fulfill the return of a boolean. Notice here what I mean here, because I'm using the add, not this add, but the add in the parent. That's what I must use super. Now this is one method to add, which is adding at the end. And if you notice here, I am using that also in my example here. So I am only using add at the end. So if I run it again now, you will see that I have unique set of element 1, 2, 3, 4 without the duplicate. Okay, but this is not the end of the story. What if I want to add at the beginning like this? What if I want to add the element at the beginning? Notice that add at the beginning or add a certain index is another method, overloaded method, and this method also inherited. So I have it already there, even though I didn't write it, but it get transmitted to the parent, to the child automatically. Now, if I run, you will see that I'm still have the duplicate. You see here's 3, 3, 1, 1, and so on and so forth. Why is that? Because I did override the add with integer, which is with the element, but I did not override the method that takes an index and an integer. For that, I need to do the same exact thing here, okay? And basically, I need to change that into integer index and element, as you can see here. And I need to write a little bit. So if it contains, okay, most probably I need to stick with the add here. Notice that adding with index and the integer, it's void, doesn't return anything. This is based on the array list. So I need to stick with that. I cannot override with this way. So I need to do void. I have to stick with the same exact method inside the parent. So here, if I can have only one statement. If I don't have the element, go ahead and add it. In this case, I can say super.add index and element. So I reuse as again the element add element at certain index, and to differentiate it from my overridden method, I am using the super element. Now, if I run again, notice I'm adding at the beginning or at 1 or wherever you want. But if I run again now, I will see that I have a unique set. Okay. Now, not only this is not the end of the story. What if, for example, you have you can still also add a collection. So one of the methods to add is to add a collection. So I can show you, I can bring the method here to you so that you can look at it. So the collection super.add, and I think we overrode these two first to add, but add all collection at a certain collection, a certain index, we did not override. That means also they can violate our class. So what shall we do in that case? You can stop at one certain point. You could do is to throw an exception to stop the usage of add all. Or what you can do is you can override the add all. Look, add all, it takes collection of integers, okay? And so you need to override them too. So you can do them. I will provide them for you at the end with the complete code for that. Now, this is for one usage of inheritance. Notice that here, I didn't bother to, for example, if I want to iterate through my array set, I still can use get. So in the set that I have, I still can add, I can clear, I can check contents. I get everything from the inheritance, as you can see. So I still have, I can get an element at certain index, I can get the size, I can clear, I can remove, and so on and so forth, automatically transmitted to me. But the problem here in inheritance in this one is that basically you need to pay attention to the method that misbehave, or the method that are candidate of not following the contract that I want, or the behavior that I want, in which I don't want duplicate in this case. Adding in general can violate that. And because of that, you have to look at them and make sure that these methods are overridden so that you can correct the behavior of them. Now let's switch again to back to the final statement here. I would say here, if you look here, array set is a array list, and this makes sense. Array set is identical or almost identical to array list. The only thing is that it's does not accept what duplicates. Now let's see how can we use composition. So composition is a different way. I think it is a very important principle in object oriented. So you can say, for example, I will call it array set 2. Okay, I will call it 2. And to do composition, we're not going to use any kind of array inheritance. Instead, I can define a reference to the array list of integer. This is my, let's say, reference, and I can say new array list, as you can see here. Now, of course, I have to fix the import here. Now I can, here what I'm saying, array set has an array list as a data member, and I can reuse everything I need here in the array list. And for that, if I go, for example, in the main method here, and I copy it, and let's see what can I have. I will switch this to 2. Okay. Now here, of course, the first error here comes add. I don't have add in my array set 2. I don't have add. Why? Because this is not inheritance. You have to provide your own methods here. Okay. So you need to say this is not overriding because I am not using inheritance here. So I have to use maybe Boolean add, and I say integer element. And basically, let me switch this to add e. Now, what shall I do here in this case? I have to use the reference to add the element to the array list, which is the reference, if it's not there. So if ref contains element, okay, let me say put not here. If it doesn't contain the element, okay, just go ahead and add it. So I will say a reference add and the element, okay. else you do nothing, and I can return true just to make it consistent with the boolean here as a return. Why did I put it? I just mimicking the array list add here. Okay, now if I run here, now it compiles correctly because I have add, and at the same time I do what here, I can set them according to what I need. Okay, now another thing, what if I want to add at a certain index, let's say 0 here. I don't have at a certain index, but I have to create an additional method. So in composition, you add method as you go, as you need. Okay, so I can also mimicking that void, and I put here the index that I want to have it here, and I need to use the reference. I don't have inheritance here. I have just the reference up there here, where I can add whatever I want. So here, if I not if the reference it's not there in the array list, I can say add it at this index. Otherwise, don't do anything. It's void. Okay. Now, if I run, also I have a unique list, even if you are using at index. Now, how about add all? I'm not providing add all in this interface or this methods. This way, we will have what? In this case, we will have some kind of interesting thing, which is we'll have something like interesting thing related to the class that I have. How about if I want to iterate through the elements here? Can I iterate through the elements here? I think run. Okay, here we go. I think I was running the previous one. Okay, so let's start over here. If I want to add all elements, okay, it works, but I am getting what here? I would think array set blah blah blah. Why do I get this? Because as a matter of fact, in the array set the first one, this one, I inherit toString method from the array list, which is working fine. But here I don't have inheritance. So in this case, you need to override the toString method. Okay, and you need to basically just return ref.toString so that you can override it. So in the composition, you have to provide the methods as you go, as you need. Okay, you don't get anything for free. You have to do them by yourself. And here we go. We got everything correct. Okay, and again, if you don't have currently, I have two methods here: add at the beginning and add at a certain index, and this what you have. Notice that here is you are restricting thing. What if you want to iterate through the array list? Let's say I want to iterate, go through the array list here. If I say set dot, I don't have get, size, is empty, contains, all kind of searching. I don't have them. Why? Because I don't use inheritance in this case. You have to provide everything by yourself. And this is called sometimes delegation. So if you want to say, I want the size of my array list, in this case, just return the reference dot size. If you want to search for an element, let's say Boolean, contains, and here integer element, you want to search for element, you can say return reference dot contains of element. This way you can add them. So you can add more as you go or as you need. So now the difference between inheritance gets you everything. You don't have to rewrite that much. Only you need to override the add methods, because add method are the method that can violate the uniqueness or the uniqueness of the elements inside the array list. But still, you still have the add, remove, you still have the remove, you still have the contains, you still have the get, and you still have the set, and so on and so forth. Okay, maybe I just remember here also you need to override the set, because the set also can violate the contract, because you could set an element with a value that already exists. So before you do the set, you have to do what to that. I will provide you the complete code for that, and you can see the difference between inheritance here, where you can edit only the methods that could be a candidate for violating what you need. The rest, if they don't violate in any case the functionality of your array set, you can leave them as they are, and you get them automatically, of course, from what? Inheritance. In the composition, you need to provide everything by yourself, and basically you need to use it over the reference here. Which one is better? It depends. Notice that in composition here, if you have control of what you want to give to the client or to the user and what you don't have to give. So here, if you decide that you don't want to provide them with a searching mechanism like contains, index of, you can just leave. You don't have to provide this method to the user. If you decide not to add all, you just don't provide odd method, and that's it. Unlike inheritance, you don't have to get that. You have to override each one that you don't want to, okay, and either you stop the functionality of it or change it according to your need. I will provide you in the notes section with the complete code with both of them, and also here's a small comparison between the two. Notice that the amount of coding in composition is more, even though it gives you more control. The amount of coding in inheritance is smaller. However, sometimes if you miss or you forget to override a certain method, you might the array set or the code that you provide might be violated by the client. That means like a backdoor where the client can violate, and maybe it will cause some problem to your code. Okay, that's what I have for this small tutorial. Thank you very much, and see you in the next tutorial.